Hey everyone, welcome to another video. Now, we've looked at quite a few videos here where we've started trying to approach working with rates, and we came up with a few strategies. Now, in this final video, in at least the main rates section, there's going to be a couple more videos in this series, but we're going to be looking at solving rate problems. So approaching a lot of really wordy questions, and particularly the last one today, you're going to see it's actually going to be quite difficult to approach, and we need to really bring together everything we've been doing so far and attack the question little by little. Now, I have two questions here to start off with. These are just out of a textbook. So let's just jump straight in because hopefully by now you're used to some of these types of questions, and we're going to move to a third one, which is quite a bit harder. But in question one, we have that Rachel can touch type at 74 words per minute. How many words can she type in 15 minutes? So let me just write this information in. So I have it takes, it takes 1 minute to write 74 words in 1 minute. Now that's just told to us in the question, and we want to see how many she can type in 15 minutes. Now this first question is actually not too different from the ones we've been doing. Well, we just have a rate per minute, and we have 15 minutes that we're trying to find for. So we just want to figure out, well, how do we get from 1 minute to 15 minutes? Or how, if I have my rate of 75 words per minute, the amount of words in 15 minutes will just be 15 lots of that. So this looks no different to how we used the unitary method before. We have 74 words in 1 minute. So to find out how much you'll get in 15 minutes, that's just going to be 15 times my 74 words to figure out, well, how many can I get in 15 minutes? If we do this multiplication, we end up getting that she can type 1,110 words in 15 minutes. So this question is slightly different because we're given a rate and we want to find a new amount of words for a new amount of time. So we're given a rate of words per minute, and now we're just trying to find how many words we can find in a certain amount of time, in 15 minutes. Now let's look at part B. So we have that Leanne works in a donut van and sells on average 60 donuts every 15 minutes. How long is it likely to take her to sell 800 donuts? So with any worded questions, we want to highlight the main bits of information. So we have 60 donuts every 15 minutes, and we want to find how long it'll take her to sell 800 donuts. So let's just write the bits of information from the question as a rate. So we have part B, we have 60 donuts let's write it down here. We have 60 donuts in 15 minutes. And something really cool about rates, at least with questions like this, is that the perspective that we look from, whether we're looking at the donuts or the minutes, we can approach it in a very similar way. Now, in the other questions so far, we've been dealing with the right-hand side of my rate, the per something, that something part of the question. But now, instead of looking at, something per minute, we're looking at how many minutes it'll take to find a certain amount of donuts. And that we can approach in the exact same way. I want to find how much how long, sorry, it'll take to sell 800 donuts. So I want to get from 60 to 800. And we can do this in a variety of different ways. I'm just going to do it using the unitary method, which we're used to doing by now, I hope. So 60 donuts in 15 minutes. Well, I can find out how long it'll take to make one donut. And I can do that by dividing both sides by 60. So that's going to give me now instead the amount of time it takes for one donut. And if I divide 15 by 60, I get a quarter of a minute. So in a quarter of a minute. So not a whole minute, a quarter of a minute, or 15 seconds. Now let's shift this down a bit. So I have this. Now all I have to do is I have to get this 1 from my unitary method back up to 800. How can I do that? Well, the great thing about the unitary method, if you remember, is that we can get any number to 1 by dividing it by itself, and we can get 1 to any number by multiplying by that number. So we can get from 1 to 800 by just multiplying by 800. And I'm going to do that because we're working with rates to both parts of this question. So I have one donut per a quarter of a minute. Now I want to find, well, how long will it take me to make 800? So I'm going to be multiplying by 800, and what I end up getting is 800 donuts in 200 minutes. Now we can convert this to hours and minutes if we'd like to, but let's just leave this as minutes. Now, hopefully you can see here that once again, every time we did these previous questions, we were working on this side. But with rates, we can kind of attack both sides of the problem depending on what we want to find. So here we were trying to find a certain amount of minutes. So the unitary method, or the just regular rate manipulation we looked at, that was dealing with this left-hand side instead. And we can do these questions in the same way using the unitary method. It was just that this time, instead of getting the right-hand side up to a certain amount, we wanted to get the left-hand side from 60 to 800. Now let's look at one last question. And this question is quite difficult. So we're going to spend a little bit of time on this. This is where the bulk of our video is going to go, because this is probably the hardest type of rate, a worded rate question you're going to get. And you can see here it involves multiple parts. Now, I have that 3 water hoses from 3 different taps are used to fill a large swimming pool. The first hose alone, so the first hose by itself, takes 200 hours to fill the pool. The second hose alone, so by itself, takes 120 hours to fill the pool. And the third hose alone takes only 50 hours to fill the pool. How long would it take to fill the pool if all 3 hoses are used? Now, let's think about what we're actually doing here. Well, we're trying to fill 3 different pools. Well, sorry, I'm trying to show 3 different hoses here filling the same pool. And just drawing that in, I have my one hose. So that's a shocking drawing of a hose, but I'm just trying to be time efficient. You know what I'm trying to, you hopefully know what I mean. I have a hose, 3 hoses, they're filling the pool, and they're filling it all at a different rate. Now, the first one, that fills it, or it takes to fill the pool alone 200 hours. So out of these 3, the one on the left, the first hose is gonna take the longest, right? It's got the slowest rate. It fills the pool quite slowly because it takes 200 hours compared to the other ones. Now, the second one takes 120 hours to fill. That one's in the middle. And the last one takes 50 hours to fill. Now, what we want to do is we want all of these hoses, 1, 2, 3, we want these to kind of be speaking the same language, right? We have a lot of different hours here, but we have no real universal way of telling, well, how much, at what rate are each of these going? Or in other words, we're told that, one takes 200, one takes 120, one takes 50, but we have no point of reference for how long these take compared to each other. We don't have a certain amount of hours that have passed in which to say, okay, this first hose has filled up this many pools. This second hose has filled up this many pools. This third one has filled up this many pools. So we want some amount of time that goes into all of these numbers, that goes into 200, 120, and 50. Because we actually want the lowest common multiple of all of these, because this is going to give me one universal number to see how many pools each of these hoses have filled in that time. So what we want to do with all of these different rates, we want to find the lowest common multiple of 200, 120, and 50. So how do we get that? Well, we just need to find the smallest number that all of these numbers go into. Now, you can take some time on your own to figure this out if you'd like, but I'm just going to go straight into it and say this is 600 hours. This is the smallest amount that all of these can fill. That's the lowest common multiple that each of these hours, 200, 120, and 50, go into. Now, this is going to tell us, first of all, this is going to tell us how many pools each hose will fill. And if we add up all of these numbers together, this will give us the total full pools that can be filled with all three at the same time. And then we can use our strategies to look at putting all these together for just one pool. So what I'm going to write here is I'm going to write that hose 1. Well, this takes 200 hours to fill one pool. So 200 hours per pool. Now, how do I get this 200 up to 600? Because what I'm doing, right, is I am using sort of like a unitary method, but I'm just trying to find how many pools will get filled in 600 hours. Now, I can do that pretty easily. I can get 200 hours up to 600 by just timesing by 3. So that means that it'll take me 600 hours for 3 pools. Hopefully that wasn't too bad, but you can see now that I am just trying to find out, okay, how much will each hose, how many pools will this fill in this universal, this same amount of time that goes really nicely into each of these numbers. Now, for hose 2, I have 120 hours per pool. So I want to get my 120 up to 600. So I want to say, well, what number multiplies by 120 to give me 600? Now that number is 5. You guys can check this at home if you want to take a longer unitary method, or you can do this in your head. But what I have here is that in 600 hours, I'll fill up 5 pools here. So 600 hours for 5 pools. And I'm going to keep going along for hose 3. And I have 50 hours per pool. Now this is the quickest hose, right? This is the one that's it's taking the least amount of hours to fill up the pool. And I want to get from 50 here to 600. And I can do that by multiplying by 12. And I get that in 600 hours, this hose will fill up 12 pools. So that means, guys, that altogether, I have in 600 hours, hose 3 fills up 12. In 600 hours, hose 2 fills up 5. In 600 hours, hose 1 fills up 3 pools. How many pools are filled in total? And so all 3 hoses together, well, that's going to be 3 pools plus 5 pools plus 12 pools. And that gives me 20 pools filled in 600 hours for all of these altogether. Now, what does that tell me? Well, that tells me that all 3 together, the rate here is going to be 20 pools per 600 hours. Or I can say 600 hours for 20 pools. So 600 hours per 20 pools. Doesn't really matter which order we write this in at this point in time. Now, I can find, well, how long is it going to take me to just fill up one pool? Because that's what the question was asking me in the end. It was asking me, how long would it take to fill the pool or fill one pool if all 3 hoses are used? Now, I want to get from 20 to 1. I can do that by dividing by 20 here, and I end up getting that one pool takes 600 divided by 20. That gives me 30 hours. So it would take 30 hours to fill the pool if all 3 hoses are used. And this kind of makes sense because we can do a little sense check, because this is smaller. It's a smaller amount of time than all of the other hoses. So if I put them all together, it should take a shorter amount of time. Now let's just quickly recap what we did for this question. We, when seeing this, underlined all the important bits of information, and we wrote down, cool, each of these hoses takes this amount of time. And we wanted a universal amount of time to try to see how many pools each of these hoses will fill compared to one another. And we did this by finding the lowest common multiple, the smallest number that each of these amounts of hours, these numbers, went into. So we wanted something that 200, 120, and 50 all went into. This is 600 hours. Now, given this amount of time, we just found, all right, well, how many pools will each of these hoses fill in this universal amount of time? This amount of time that goes into each of the 3 that we were given. So I had 3 pools, I had 5 pools, I had 12 pools, and combining those all together, I expressed that, well, I can fill up 20 pools in 600 hours. So 20 pools will take 600 hours to fill, and using the unitary method, which we've been doing up until now, I found, well, okay, how much time is it going to take for one pull in order to answer the question? So there's a lot more steps, guys, but the essence of these types of rates questions is getting everything to the same, a same unit, to the same amount. Now, we didn't have to pick 600. We could have picked another lowest common multiple or another number, but it would have been really messy. But if you remember, rates deal with quantities, right? So we wanted to get all of these expressions for rate to some kind of same measurable quantity for each of these. And that was this idea of 600 hours. We had the same quantity across the board, and we had a bunch of different rates, which we could add together and then use our unitary method to solve for. Thank you so much for watching, guys, and I'll see you in the next video.